discuss solving quadratic equations by factoring. Example number 1. 4m squared minus 12m is equal to 0. What are we going to do with this equation is to get the common monomial factor of 4m squared and 12m in order for us to get the factors of this polynomial. So in solving for the common monomial factor of 4m squared and 12m, we are going to first get the numerical coefficients. Let's say for 12. Now, 4 and 12 is our numerical coefficient. We will get the prime factors of 4 and 12. So for example, for 4, we have 2 times 2. And for 12, we have 2 times 2 times 3. Now we will get the common factors of 4 and 12. So this one, common factor, the first 2 and the second 2. So if we will get the common factors, we have 2 times 2, which is equal to 4. In the numerical coefficients, the common factor is 4. And for the literal coefficient which means variables, including the exponents. So we have m squared and m squared and m. So we're going to get the variable with a lower exponent. So in this case, for m squared and m, the lower is m. Therefore, it will be partnered and it will be paired to 4. Therefore, the common factor is 4m. So we will separate 4m. So we have 4m. Then we will solve for the remaining terms inside the parentheses. So how do we do that? We divide each term by the common factor. So we have 4m squared divided by 4m. So we have 4m squared divided by 4m. We cancel 4 and we expand to m times m over m. We cancel it, so the remaining term is m. Therefore, on the first term, we have m. Now, on the second term, 12m over 4m. So we will cancel m. So the remaining is 12 over 4, or 12 divided by 4, which is equal to 3. The sign here is subtraction since our original polynomial operation that separates the two terms is subtraction. So we copy it equal to 3. Now, by zero product property, we will separate 4m and m minus 3. Since the zero product property states that if AB is equal to 0, then A is equal to 0 or B is equal to 0. So we have 4m is equal to 0 or m minus 3 is equal to 0. So, in order to eliminate 4, we will divide both sides by 4. So, divide both sides by 4. So, we have m is equal to 0. 0 divided by 4 is 0. And then we cancel 4 here. So, m is equal to 0 or m is equal to 0 plus 3. We transpose negative 3 to the other side of the equation. By meaning of transposition, it means we transfer one term to the other side of the equation and changing its sign. So from negative 3, it will go to positive 3. So m is equal to 0 plus 3 or m is equal to 3. Therefore, the solutions of 4m squared minus 12m is equal to 0 are m is equal to 0 or m is equal to 3. This is our solution set for the quadratic equation 4m squared minus 12m is equal to 0. So we have example number 2. H squared minus 9h plus 20 is equal to 0. Our trinomial here or our quadratic equation is considered complete since we have the quadratic term, the linear term, and the constant term. When we say that the quadratic equation is complete, all three terms, the quadratic, linear, and the constant terms are present in the equation. So we have this example, h squared minus 9h plus 20 is equal to 0. So what are we going to do is to factor first the first term or the quadratic term of the equation. In this case, h squared. So we have h squared minus 9h plus 20. So we have to factor h squared, in this case h and h. We will separate the factors of h squared into two factors. So the first one is h here on the first factor and another h on the second factor. Now our next goal is to find the partners of h. And in this case, we are going to look at our third term or the constant term. Our constant term is 20. What are we going to do is to list down all the factors of 20, and then later on we will investigate whether if the sum of those factors will be equivalent to negative 9, since our second term of the quadratic equation or the linear term in the quadratic equation has a numerical coefficient of negative 9. Take note that our third term is positive. Our third term is positive and our second term is negative. Therefore, the two pairs or the two factors must have a negative sign, since our second term is negative and our third term is positive. If our third term is positive and the second term has a sign of positive, then the factors are all positive. But in this case, negative yung ating second term. Therefore, ang factors dapat ng 20 is negative. So, to get the factors of 20, we have factors at 20 and 1, 20 times 1, 10 and 2, 5 and 4. Since our sign on the second term is negative, therefore all terms are negative. Then we will proceed to addition. We will add the pairs of factors present on 20. So for instance, we have negative 20 plus 1, we get negative 21. Negative 10 plus negative 2, we get negative 12. And negative 5 plus negative 4, we have negative 9. On these three pairs of factors, we will investigate who among those three pairs of factors has a sum which is equivalent to the numerical coefficient of the second term. So in our investigation, we saw that this pair, negative 5 and negative 4, has a sum of negative 9, which is equivalent to the numerical coefficient of the linear term, which is negative 9. So therefore, negative 5 and negative 4 must be paired to h here. So in this case, of h minus 5 and h minus 4 is equal to 0. Then by zero product property, we have here h minus 5 as one factor and h minus 4 as one factor. Therefore, we can tell that h minus 5 can be equal to 0 or h minus 4 is equal to 0. So h minus 5 is equal to 0 or h minus 4 is equal to 0. By transposition, so we will transpose negative 5 to the other side of the equation as well as negative 4. We have h is equal to 0 plus 5 or h is equal to 0 plus 4. So 0 plus 5 is equal to 5 or h is equal to 0 plus 4 equals 4. Therefore, the solution set of h squared minus 9h plus 20 is equal to 5 are equal to 5 or 4. That means that the value of h can be 4 or the value of h can be 5. So therefore, this is now our solutions of the quadratic equation or the roots of the quadratic equation. So we have example number 3. 3x squared minus 8x minus 3 is equal to 0. So our case here, the numerical coefficient of the quadratic function or of the quadratic term is not equal to 1. In this case, we have 3. So we are going to apply what we call the AC method in factoring quadratic trinomials whose A is not equal to 1. So we will apply the AC method wherein we will multiply the values of A and the values of C. Then we will find the factors of that AC and it will connive to letter B. So we have here, since we follow the AC method, so AC is our A in this case 3 and our C in this case negative 3. So 3 times negative 3, this is equal to negative 9. So we will find the factors of negative 9 that will sum up to negative 8, which is the value of B. So the factors of negative 9 are negative 9 and 1, 9 and negative 1, and 3 and negative 3. Those are the factors of negative 9. So we will add this. We will add this already. The negative 9 plus 1 is negative 8. 9 plus negative 1 is 8. And 3 plus negative 3 is 0. So, our factors of negative 9 that connives, if we sum up those factors, those pairs of factors, the one that connives with letter B is this factor. Negative 9 plus 1. Since negative 9 plus 1 is equal to negative 8 and negative 8 is the numerical coefficient of our linear term. So, with this coefficient, we're going to split. We're going to split negative 8x with these factors. So, we will split now negative 8x into negative 9 and positive 1. So, we will, since negative 9 and 1 is our factors, we will put x on that so that we can separate negative 8x into negative 9x and positive 1x. So we have 3x squared minus 9x plus x minus 3 is equal to 0. So we separated already negative 8x into negative 9x and x, the factors that we get in negative 9 a while ago. Then, we will split again the equation into two. The first two terms will be one group and the last two terms will be another group. So in this case, we have 3x squared minus 9x plus x minus 3 is equal to 0. In this case, we will not be able to factor it already since x minus 3 is already a prime factor. But in this case, 3x squared minus 9x, we're going to factor it using common monomial factor. And if we're going to follow the steps that I showed you a while ago during our first example, we're able to find out that the common factor is 3x. Then by division, 3x squared divided by 3x is x, and negative 9x divided by 3x is negative 3, plus x minus 3 is equal to 0. Now, we get the factors of 3x squared minus 9x, or 3x and x minus 3. Then we have here x minus 3. These two is considered two terms. This one is one term and this one is another term. there is a common factor between those two terms. And that common factor is the x minus 3. This is their common factor. So we will separate the common factor x minus 3. What's left are those terms which is not separated, which is not joined by x minus 3. So in this case, in 3x and x minus 3, we cancel out x minus 3. The remaining is 3x. And the other one here, since there's no factor, there's no other factors, we consider it, the remaining is 1. Since x minus 3 divided by x minus 3, this is equal to 1. So we get the factors already of 3x squared minus 8x minus 3 using the AC method. By zero property, we will separate x minus 3 and 3x plus 1. So we have x minus 3 is equal to 0, or 3x plus 1 is equal to 0. By transposition, we will transpose negative 3 to the other side of the equation, as well as positive 1 to the other side of the equation. That will become x is equal to 0 plus 3, or 3x is equal to 0 minus 1. X is equal to 0 plus 3, x is equal to 0 plus 3 is 3, or 3x is equal to negative 1. Since 0 minus 1 is equal to negative 1. Then this 3x minus is equal to negative 1, we will eliminate 3 here. So we will use the division property. So x is equal to negative 1/3. Therefore, the value of x in this equation, 3x squared minus 8x minus 3 is equal to 0, or x is equal to 3, or x is equal to negative 1/3.